the answer to that quiz. I still remember it. It's problem number 36, right? So let us do the quiz and then see what else this section has. Looks like we stuck on it, but it's worth to clearly understand the meaning of probabilities that we were working on for a couple of class meetings. So for the given sample above, and the sample deals with all of the outcomes when you roll 2 dice or 1 die 2 times, doesn't matter. The question is find the probability to get both odds when you get this type of sample. So sample is a set of all possibilities. For example, if you get 1 and 1, both odds, 1 and 3, 1 and 5, right, etc. So how many of them are here? It looks like I need to look only at the first, third, and the fifth rows in this little table, because second, fourth, and sixth have already 1 even, and out of total of 36, we care only for 9, which is 1 divided by 4, or 0.25. So the answer to the quiz is 1/4 or 0.25. If you didn't do this problem or didn't do it right, that's fine. All you need is just to do another even exercise instead. For example, like number 38 or 40. Right? So any problem that is even works to make up for a quiz, and make a picture and send me your work by email anytime when you feel like it. So this quiz exercise is 36. You want to do 35 for 2 even numbers? Sure, we can also do that. So we can try number 35. I think the answer will be exactly the same, right? So if you get 35, it's 2, 2, 2, 4, 2, 6, 4, 2, 4, 4, 4, 6, and then 6, 2, 6, 4, and 6, 6. So to get evens, we also get 9 out of 36, which is going to be 1 out of 4, or 0.25. So very similar exercises are here. So anyways, I hope you start to feel better about this probability stories, and let's check out and see what else is in this section. So there are various other questions, of course, and here on the bottom of this page, you can see some exercises related to diagrams. So I'm not planning to rush through these sections. I want to take time and make sure that we all feel good about these exercises, producing those fractions that correspond to probabilities. So let's check out exercise 41. And again, I'm waiting for your questions. If you have any, please don't hesitate. I'm here to help you with these homeworks. So I selected some odd problem from another group of exercises where we have some type of circle-like diagram. So let's try to see what if these are all equal slices. And looks like we need to see how many of them are here. They actually told it's 10. So what's the probability to get red here out of 10 regions? And looks like I see 3 reds, right, out of 10. So 3 over 10 will do. or you can say it's 0.3, which is the exact same thing. So let's check out exercise 25. Let's scroll up a little bit. That is dealing with the case when family, or actually 25, it's a head on the second toss. So let's see what this is all about. I need to go to the previous page to see what type of experiment they're talking about. So in the exercise 21 through 26, they have this type of example. So it looks like they toss a coin and they can get either head or a tail as the outcomes. And when first is head, it should be either head or tail for the second toss for the same coin. Or when first was a tail, then again, it's either head or tail. So that's how they produce the sample of 4 possibilities. So this consists of both heads, head, tail, tail, head, and both tails. So this is 4 cases that we should work with. And now question number 25 says a head is on the second toss. So we need to find probability that first could be anything, but the second is head. So how many out of these 4 we see in here? So it looks like I see 2, you see them, with head on the second toss. So we don't really care what be on the first. It could be either head or tail. So we have 2 choices out of 4. And this is 1/2, 1/2, or 0.5. So we'll try to put the answers with decimals whenever I can, because, well, it's more convenient for the future. In the future sections, we will deal with decimal answers only, because the answers are not going to be as nice. But it really doesn't matter if you put 1/2 or if you put 1 over, or if you put 0.5, same thing. So let's check out what's on the next page. In fact, the last page of this section before the concepts on the exercises. So let me look at this story that deals with a couple of tables in here. So for that, I guess I want to use eraser and clean this a little bit. So we can check out the exercises related to the table. Let's start with problem number 61. So let's see what this is all about. It says the above table to find probability. And in the problem number 61, they're talking about the owners. So it looks like here's the story that they have for us. It looks like they're interested in all of the owners in here. Let me see what else is related to this section. Here it says, the table shows a number of Americans who moved, and we can use this data expressed in millions. So those are millions of people that moved. Okay, so that's helpful to know, right? Otherwise, it'd be hard to understand what they're talking about. So it looks like I need to add all of those numbers to produce totals. Why do I need to add all of those? Well, because we need to have a total in denominator. So if I start adding, I'll get 14.8 in the first row. Please notice it's all in millions. And if I add numbers in the second row, I'm gonna get something like 22, 23.2, 24.2, right? 24. So, and the grand total that I really looking for here will be something that looks like 7 and then 3. So it turns out that 37 million, or you could just say 37 in terms of millions, was total that moved. So an exercise number 61 that asks to find probability that it was a owner of the property that moved, then out of this 37 million, out of grand total, how many of our interest? Well, looks like the story related to owners is a first row, right? So it'd be a 14.8 total. Let's see, why'd you add all those? Well, because there are some owners that moved in the same state or the different state or the different country. So all kinds of possibilities, but what they ask is all of the owners, so the total of the owners that have moved, and looks like total was 14.8. And of course, I better use a calculator here, so I will enter this fraction 14. Oops. Enter this 14.8 and divided by, oh, I think I misclicked and I lost my total, right? So I better redo this real quick. So what was that one? 14.8 here, right? And here we have
24. Yeah, 24.2.
24.2. Thank you. Thank you so much. 24.2. So when you add these together, so I got some like 37. Thank you. Thank you. That's helpful. So let me see. It's so easy to just misclick somehow and get the wrong answer, right? So divide by 37. And here we have 40%. So the answer is probability that we have owner that moved is
I think that's 39. The 8 plus 2 is 10. You carry the 1, that's 9.
yeah, you're very good at that. Thank you. I appreciate it.
No problem.
Practice. I will practice my arithmetic a little later today. I think I need to refresh skills. Thank you. That's very good that you're double checking it. So it looks like we ended dividing 39, right, by, oh, actually we divided 14, so I should wake up, I think. Need to wake up, Alex, wake up. So 14.8 by 39. And get the answer. It's about what? 3794. When you say, so I put 37 or what? Well, just put a few digits. It's not taking too long. 94. So the point of story is about 37, 38. Some people will say about 38% moved. So, okay. Looks like the owners don't have such a tendency to move as tenants. So probably that's what you can make as a conclusion for this. Okay, so we have answered the first part, actually exercise 61. Let me do one more and then maybe we can see what else is going on in this sections. Move to the next section. Let me try exercise like 66, the last one from this. Find the probability owner who moved to a different state. And looks like this will be the number that I'm interested in. problem 66. So owner moved to the different states. State will be a probability which is, looks like out of 39 million. Again, I just care about 11.7. And for this type of exercise, I definitely need a calculator, because without it, it'd be very difficult to simplify this fraction. It is possible, but you don't want to waste time on doing all this arithmetic. You just put it carefully in a calculator. So I put 39 here, and looks like it's a nice and neat result, 0.3 or 30%. So we have ourselves section that deals with fractions. So we always put in denominator of the fraction total, and a numerator of the fraction everything that they're asking about, the number that fits their description. So it looks like problem number 70 ends this group of exercises, so we can check out what's next, what's in the next story, and notice that it continues with probability. In fact, this whole chapter will deal with probabilities. So let me just do some more little exercises here, and that's all. So you want to go back to exercise number 66. Okay, let's do that. So number 66 is here. So it says probability of an owner. So I have to deal with those owners that move to different state. So I should be careful reading it. And that's good that you're also double checking. So it is owner that move to different states. So
Wanna be the, okay, so the right here in the next column, let's say the 2.8, that's not the number they're asking for?
Owner, oh yeah, you're right. See, you're better than I at this group of exercises for sure, because I'm not reading it carefully. Yes, yes. Thank you.
I was just making sure, so when I do the
for
numbers, like
double checking this. So my exercise is 66 was not very lucky problem for me. I think the problem that I actually did, I should have actually wrote it here. The owner that moved to the same state. So the probability I found here was of the owner that moved to the same state. And that wasn't 66, that's different. So the one that they want is owner. See, it's better to clarify in the parentheses, so that way we never go wrong. That moved to the different state. I wasn't careful. You're absolutely correct. Thank you so much for double checking. So this is actually here, right? So the owner is first row, but the different state is 2.8, not 11.7. So I need to be picking the correct number out of this table. So yeah, I need to be careful, and that's great that you double checking. So let me real quickly calculate this little fraction. So 2.8 is divided. Yeah, with this time change, I think it's still a different time in I experience. So I'm still kind of asleep. But we're saving time. That's a good thing to know. I'm glad that you woke up on time, so didn't miss it, right? So that's about 7%. That's the one that we have. Okay, so it looks like it was fixed, and now we deserve to go to the next section. So let us actually do that. So it looks like the owners don't have tendency to move far, right? So it's a different state. They much less owners moved compared to the same state. So anyways, let us go to the next section that has more questions on probabilities. And I don't think it'd be any different idea than in the previous section, but we'll just have a little bit more challenging looking exercises. That's probably all it is. So today I plan just to start with this section, so we can just look at problems here on this page with exercises, I guess, just from page that I opened here for you. So maybe I can clean everything from before. So stop share and then share this again. And let's try problem, let's say number 2. So our goal will be just to do as many problems as we can here. So feel better and better about all that. So I'm doing problem exercise number 2, and now we're in the section, I believe it's 11.5. Yeah, 11.5 here. So in this exercise, they talking about 3 men and 3 women that line up for the checkout counter. So the question is how many ways they can line up. So what are they talking about? Well, looks like there are 3 men and 3 women, right? That trying to line up at the counter. So how many possibilities can we have here? Well, let us say if we have 6 of these choices, then what I can do is from these 6 choices for position, I can select 3, right? From 6 positions, I can select 3 and put, let's say, men on these positions. So let's say we selected that one, and that one. So once you put 3 men, then the remaining 3 will fill with women. So technically we're selecting 3 positions and put 3 men on them. I say, Alex, no, put women first. Okay, so you can select 3 positions and put 3 women, and then the remaining you will fill with men. So it'd be the same exact result at the end of the day. So from 6 you choose 3. The question is, do you care about order of those? And the answer is, looks like not. Remember, we used combinations for this. Why not? Well, because we don't arrange those men. So if I put the, say, tallest man on the first position and shortest at the last, it would be treated same as if I put shortest on the first and tallest on the last. So if I switch people around those positions, it wouldn't really matter. It'd be the same thing, because all they care about how many ways you can put 3 men and 3 women. They don't give us any information extra. They don't tell us, let's arrange them or give them, assign them some particular spots. No, we just put men and women, and we see on this position, is a man or a woman? So we don't really give any other description in here. So it looks like I just need to get a combinations for this. Do you still remember how we calculate those? I take a calculator and get this functions right here. Remember, main menu, the function menu. So in the last row, there's a number of combinations. And then I go back to main and put 6, 3 in the parentheses. And I get the result, 20 is the answer. So they ask me for number of ways to line up people there. So, okay, so we put 20 for the answer. Okay, that's great. So part B says, in how many ways can they line up? So that was 2 part A. So let's do 2 part B. If the first person in the line is a woman, and then the alternates by gender. So now we really have something that we 3, 4, 5, 6. So first position is for a woman, right? And then they alternate by gender. So this be a woman, a man, a woman, a man, and so forth. So it looks like we don't really have any choices here, right? A woman, and here will be a man, and a man, and a man. So looks like they don't have a choice, but just one. So you put woman, man, woman, man, woman, man, and that's it. Please notice that we don't really start to say, okay, so we had the this woman in the first position or the other woman in the first position. So we don't really looks like make a difference, right? So we just want to put a woman, any woman in the first, and then any man in the second, and so forth. So I guess it's just only one possibility, exactly what they told us. Again, because we don't care about the order. If we did care, if we say, no, 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 do I put that woman in the first position or the other? Well, then it'll be different. But looks like they don't, all they care about is just whether it's a woman and whether it's a man. So we don't really say tall or short, or we don't assign them, we don't arrange them, in other words. That's the idea. So find the probability that the first person in line is a woman and the line alternates by gender. So what's the probability of that? Well, that probably could be a good question to ask you here, because if we have the probability that first is a woman and the line alternates by a gender, so it means they trying to get this B here, and that's only one. And the total number of possibilities is in the part A. That's 20. So it looks like it'd be out 1 out of 20, right? Why is that? Well, probability is a fraction. So we have fraction with total in its denominator. So there are total number of ways to put those people, 6 people into that line will be 20. But there is only one out of these 20 will be exactly woman, man, woman, man, woman, man. So one possibility out of 20. As usual, this is a fraction. So that's not surprising because our probabilities are always fractions. So looks like we'll be producing exercises here that have part A total, part B is what we need, and then part C is like dividing and producing probability. Let me try exercise number 4 for you. And maybe you will try those odd ones on your own, one of them. So here we have different performers. Please notice now we don't just have a bunch of men and women without any particular names or anything. Now we do give them names, A, B, C, D, and so forth. So 7 performers. So now it will make difference if you start to switch them around. So now it looks like we're going to deal with permutations. So let's see what happens now. So to order, the order of performance is determined by random selection. So now we need to find probabilities. So the difference in the previous exercise is they didn't ask you for a probability in every question. So now they ask for a probability in every single question in here. So probability to get a D on the first position. So what would that mean? Well, looks like I need to think about total number of ways to arrange those people. Please notice that out of 7 people, I choose all 7, right? So total will be permutations from 7 performers. Choose all 7, right? So we can actually calculate this by getting either factorial or just permutations. So I'm going to put permutations, go back to main from 7, put comma 7, like that. And I get 5,040, right? 5,000. So that's total number of ways to arrange people in this, I would say, a row of 7 possibilities. So now the question is, what will satisfy to the part A that says, what was it? Oh, D. D will perform first. So what does that mean? Well, there's 7 spots. We put D on the first position. So 6 will remain. So it looks like total number of ways to put D on the first position will be rearranging all the rest. So rearranging all the rest will be permutations. Out of 6, choose 6. So out of 6, we take all the 6 and we switch them around. Please notice that D is always already taken. So we no longer have D here. We just have A, B, C, and then E, F, G. So we have 6 only. So I can also get this number in here. So we got the number permutations, right? And then 6 comma 6. So I go back to main, put 6 comma 6. So I get 720. So question in the part A, what's the probability of that to happen? So probability of D to be on the first position will be a fraction with denominator 5,040. That's the total that I divide into the number of choices when D is first into 720. And please notice that you definitely don't want to start simplifying this fraction because it's going to take you a while. So all you do is just divide 720 by denominator 50, 40 and get the answer. Looks like it's about 14%, so it's a 0.142. Dun, dun. So looks like the last step, producing probabilities, is pretty much the same. So how about if I do part B by preparing where denominator, total is the same. So total looks like will be the same for all of this. So this part B says, how about if E is 6 and 7 is and B is 7? So what do we have now? So 3, 4, 5. 6 will be E, right? I put E on the 6th position, and B will be on the 7th position. So how can we find probability of that? Well, looks like now I need to see how many we have for the selection with E at 1 before last and B on the last. And looks like since there are 5 of those, we have permutations again. From 5, choose 5. Why do we choose from 5? Well, because we don't have all sevens anymore because we already filled the spots with B and with E, so they're gone. So we just have left with 5, and we can rearrange those 5 any way we can in the first 5 positions. So I can calculate these permutations just like we did in the previous part, right? Permutations from 5 to select 5. So this be 120, right? So now the question of exercise. So what's the probability that we have E at the last and B at the end? Looks like it's all prepared. So all these 5 positions we don't really care about. And this could be a good question for you to calculate. So what about if we have this for a quiz for today? What do you think the probability of that is gonna be? I already have all the pieces for you here. I already have calculated. Looks like this will be numerator, right? And this total will be denominator, just like in the part A of the exercise. So looking at part A, please answer the question they have. And the question again is actually part B. So that'd be a quiz exercise for today. So I have both pieces prepared for you. So it looks like you just need to carefully put this in a calculator. So please don't hurry and give the answer. Stop. So record.